Question 3. A. Describe what is meant by dynamic equilibrium. This is an easy one. If the system exists in closed container and the rate of forward reaction is equal to the rate of backward reaction so that the concentration remain constant is called dynamic equilibrium. Let's consider a reaction. So A is our reactant and from there we will get the product B, and there is an equilibrium between A and B. So in case of dynamic equilibrium, the system will exist in a closed container and the rate of the forward reaction, which means A to B, will be equal to the rate of the backward reaction, which is B to A. So that what will happen? The concentration of A and B will remain constant. Suppose the concentration of A at equilibrium is 2 mole per decimeter cube and for B it's 1. So in case of dynamic equilibrium, this value will remain unchanged. But the concentration of A and B doesn't have to be equal. So that's it. B. Reaction 4 describes the reversible reaction between yellow ferric ion and the colorless thiocyanate ion to produce ferric thiocyanate ion. Reaction 4 is given. So the color of iron is yellow, ferric ion, and for the thiocyanate it's colorless, and the product, which is FeSCN2 plus, is red. An equilibrium mixture contains ferric ion, thiocyanate and ferric thiocyanate. A few colorless crystals of soluble potassium thiocyanate are added. The mixture is then left until it reaches equilibrium again. The temperature of both equilibrium mixtures is the same. This is very important. 1. Deduce the changes that occur, if any, in the equilibrium mixture after potassium thiocyanate is added compared to the original equilibrium mixture. So if we add potassium thiocyanate, what will happen? In the mixture it will undergo ionization, which means we will have potassium ion and thiocyanate ion. So in case of reaction 4, potassium ion doesn't have to do anything with reaction 4, so we can skip that. But when we will add more thiocyanate, what will happen? The rate of forward reaction will increase, because if we increase the amount of thiocyanate, it will react with more ferric ion and will produce ferric thiocyanate. So changes in appearance. We know that the color of the product is red, so it will change from yellow to red, and definitely when we will add extra thiocyanate, the color will be darker, so we can write darker red. Change in relative concentration of ferric ion. So if you see reaction 4, when we will increase the thiocyanate ion, it will react with available ferric ion and will undergo forward reaction. So definitely the concentration of ferric ion will decrease. Change in value of the equilibrium constant Kc. So there will be no change in the value of Kc. Why? Because the temperature of both equilibrium mixture is same, so there is no change in temperature. So always remember, even if we change the concentration but the temperature remain unchanged, the value of Kc, equilibrium constant, will be same. The expression For the equilibrium constant Kc for reaction 4 is shown. Here is the equation. So here 5 into 10 to the power minus 4 mole of ferric ion and same number of mole of thiocyanate are added together and allowed to reach equilibrium. And the total volume of the mixture is given, which is 25 centimeter cube, or we can write 25 into 10 to the power 10 to the power minus 3 decimeter cube. So we can write it like this. Okay. Now at equilibrium the concentration of FeSCN2 plus is 4.23 10 to the power minus 4 mole per decimeter cube. So this one is given. Calculate the equilibrium constant Kc. So to calculate this, we need the concentration of ferric and thiocyanate. Initially, the mole of ferric ion is given. For ferric and thiocyanate, the number of mole is same, which is 5 into 10 to the power minus 5. And initially, the number of mole of the product will be 0. When the reaction reaches equilibrium, what will happen? It will give 4.23 into 10 to the power minus 4 mole per decimeter cube of the product. So, we know the number of mole of the product and we know the volume, which is 25 into 10 to the power minus 3 dm cube. So, from there we can figure out the number of mole. So, here is our concentration mole per decimeter cube and this is the volume in decimeter cube. From there we will get mole of ferric thiocyanate 2 plus is 1.0575 10 to the power minus 5 mole. So, this is the reacted mole. We can write reacted mole just to better understand. So, at equilibrium, the number of mole of the product is 1.0575 10 to the power minus 5. If we subtract this amount from the mole of Fe3 plus and thiocyanate ion like this, we will get the mole of ferric and thiocyanate ion at equilibrium, which is 3.9425 into 10 to the power minus 5 mole. For both it's same. From there we can calculate the concentration. We know the number of moles. We know our volume, which is 25 into 10 to the power minus 3 decimeter cube. From there we can write concentration of ferric ion is equals to 3.9425 10 to the power minus 5 mole into the volume. From there we get 1.576 10 to the power minus 3 mole per decimeter cube. And the concentration of thiocyanate ion will be exactly the same. So, the equilibrium concentration for ferric ion and thiocyanate is 1.576 into 10 to the power minus 3 mole per decimeter cube. And the concentration of the product is given already. So, here is the equation for Kc. We just have to put the values here. And from there we get 170.3. This is the value of Kc. And what will be the unit? We have 1 mole per decimeter cube on top and 2 mole per decimeter cube at the bottom. So, we can cut this 2 and then we will have 1 by mole per decimeter cube. So, we can write decimeter cube mole to the power minus 1. So, the unit is this. Hope you get it. Now, see, determine the full electronic configuration of ferric ion. We know the atomic number of iron is 26. So we can write 1s2, 2s2, 2p6, 3s2, 3p6. As we know, iron is a transition metal, so we will write the 3d orbital first and then 4s. But in case of putting the electron, we will fill up the 4s orbital first. So we will write 4s2 and then 3d6. So this is the electronic configuration of iron. So if we, for ferric ion, we have to remove 3 electrons. So what we will do? We will remove the outermost shell electron first, which is 4s2, and 1 electron from 3d. So we will write for Fe3 plus, it will become 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. That's it. D. Thiocyanate ion is colorless. Complete the dot and cross diagram in figure 3.1 to show the arrangement of outer electrons in an thiocyanate ion. So we know that for carbon the valence electron is 4. So we have put 4 electrons, 1, 2, 3, 4 for carbon. Now for nitrogen we have 5 outermost electron. So 1, 2, 3, 4 and 5 for nitrogen. And for sulfur we have 6 electrons, 6 valence electrons. So we have put 1, 2, 3, 4, 5, 6. So this is the dot and cross diagram, but we have a negative charge here. So for this negative charge, there will be 1 electron in sulfur. Now this is the dot and cross diagram for SCN minus ion. And that's it. Thank you.